13.8 billion years ago, the universe began in a single moment where there was nothing, and the next, everything. But what exactly is nothing? We spend our lives focused on the things we can touch, the stars, the planets, the ground beneath our feet. Yet, when we look up at the night sky, the vast majority of what we see is actually the darkness between the lights. Tonight, we will turn our gaze away from the stars and peer into the shadows. We will walk through the immense gaps between galaxies, where silence reigns for millions of light years. We will peel back the layers of reality to ask if empty space is truly empty, or if it is actually alive with a hidden, bubbling energy. This is a story about the architecture of emptiness. So, let the noise of the day fade, and let's drift together into the quiet, heavy comfort of the void. To understand the concept of nothing, we must first look at what surrounds us right now. You're likely resting in a room, perhaps with the lights dimmed, the world outside quieted for the night. It feels peaceful. It feels empty. If you were to close your eyes and reach out into the darkness, your hand might pass through the air without resistance, grasping at what seems to be a void. We intuitively feel that space is a container, a box that can be filled with things like furniture, books and people, or emptied until it is barren. When the room is quiet and the objects are still, we say there is nothing happening. When we clear a table, we say there is nothing on it. But this is an illusion. The empty space in your room is not empty at all. It is in fact a crowded, chaotic and dense ocean of activity. To find the true nothing that we are searching for tonight, we have to perform a mental experiment. We have to strip away the layers of reality one by one, peeling back the skin of the world to see what lies beneath. Let's begin this process right here, in the safety of this room, by using the power of your imagination to dissolve the world around you. First, imagine removing the obvious things. In your mind's eye, take away the furniture. The chair in the corner, the shelves, the bed you're resting on. Let them fade into mist and disappear. Now, take away the walls, the ceiling and the floor. You're floating now, suspended in a dark, quiet space. It seems as though you have achieved emptiness, but you haven't, not even close. What remains, pressing against your skin, filling your lungs and swirling around you, is the air. To us, air feels like nothingness, a ghostly absence that we move through effortlessly. But to a physicist, the air is a thick soup of matter. It is composed of nitrogen, oxygen, argon, and traces of other elements, all behaving like a swarm of tiny hyperactive bees. Even in the stillest room, where the air feels dead calm, the molecules are moving at hundreds of kilometers an hour, colliding with one another, and with you billions of times every second. These atoms are the descendants of cosmic history. As we know, hydrogen and helium were the first elements born in the first few minutes of the universe. But the oxygen you are breathing in this moment, and the carbon and nitrogen that make up the dust floating in the imaginary void, were forged much later, in the hearts of stars that burned and died long before our solar system was born. So, this empty air is actually a graveyard of ancient stars, a swirling museum of cosmic ash. It is very much something. So, let's go further. In our thought experiment, let's activate a giant imaginary pump. We'll suck every single molecule of air out of this space. We pull out the nitrogen, the oxygen, the argon. We scrub away the microscopic dust motes and the floating pollen. We create a perfect vacuum, far purer than anything that exists in the best laboratories on Earth, or even in the space between planets. Now surely we have nothing. It is dark. It is silent. There is no air to carry sound. There is no matter to touch. If you were to try to breathe here, there would be nothing to inhale. But if we look closer, with eyes capable of seeing the invisible spectrums of the universe, this vacuum is still blindingly bright. The universe is filled with light. Even if your room is pitch black to your human eyes, it is awash in electromagnetic radiation. Your body itself is glowing. You're emitting infrared radiation, a form of light that we experience as heat. The walls we removed, the ground beneath, the atmosphere above, they're all radiating energy. And then there are the signals. Passing through your body right now, at this very second, are radio waves carrying music, Wi-Fi signals carrying data, and cellular signals connecting voices across the globe. We're unaware of at least 99% of what is occurring within the universe because our biological senses are tuned to such a narrow band of reality. If we could see radio waves, your empty dark room would be a blazing riot of information and noise. So, we must be ruthless in our subtraction. We must turn off the radio towers, silence the satellites, and block out the heat of the Earth. We have to build an imaginary box around us that shields us from every form of electromagnetic radiation. No light, no heat, no radio. Just cold, dark silence. Have we reached nothing yet? Not quite. Streaming through the roof of your house, passing through your shielding box, and zooming through your own body right now are ghostly particles called neutrinos. These are subatomic particles that were produced in the nuclear fires of the sun and in the violent explosions of distant stars. They're incredibly elusive. They barely interact with matter at all. They fly through the Earth as easily as light flies through a glass window. In the time it takes you to take a single breath, trillions of these neutrinos pass through you. They are the silent witnesses of the universe travelling from the core of the sun or from a supernova that exploded 168,000 years ago in the Large Magellanic Cloud. They flood the empty space we're trying to create. To truly have nothing, we would need to block these out too, a task that would require a shield of lead light years thick. But for the sake of our sleep, let's imagine we can snap our fingers and banish them. The neutrinos are gone. We're getting closer. The matter is gone. The air is gone. The light is gone. The ghostly particles are gone. It is just deep, absolute blackness. But there is still something here, something that acts like an anchor, keeping you tethered to reality. Gravity. Gravity is the curvature of space-time itself. It is not just a force that pulls things together. It is a property of the universe that affects all matter and energy. Even in our empty box, the gravity of the Earth is pulling on you. The gravity of the Sun, the Milky Way, and the distant Virgo supercluster is tugging at the very fabric of the space you occupy. You cannot simply remove gravity, because gravity is the shape of the space you're sitting in. As Albert Einstein conceptualized, gravity is the warping of the fabric of reality. To remove gravity, you would have to remove the universe itself. You would have to flatten out the curves of space-time caused by every star and galaxy in existence. But let's pause the subtraction for a moment and look at the stuff we removed. The furniture, the walls, even your own body. We tend to think of these things as solid. We think of nothing as the space between objects. But if we zoom in on the objects themselves, we find that the boundary between something and nothing is dissolving. Let's take a single atom from the chair we removed. Hydrogen, the simplest atom, the most abundant element in the universe. It has a single proton in the center and a single electron whizzing around it. We often picture atoms like tiny solar systems, with the nucleus as the sun and the electron as a planet. But this analogy fails to capture the scale of the emptiness inside an atom. If the proton at the center of a hydrogen atom were the size of a basketball sitting in the middle of a stadium, the electron would be a tiny speck of dust buzzing around the outer seats of the stadium. Everything in between the basketball and the dust speck, the vast cavernous interior of the stadium, is empty space. This means that the solid matter of the universe is almost entirely made of emptiness. The atoms that make up your body, the bed you lie on, and the air you breathe are 99.99999999999% empty space. The solidity you feel, the resistance of the floor beneath your feet, is not caused by solid matter touching solid matter. It is caused by the electromagnetic force fields of atoms pushing against each other. It is force, not substance, that you feel. When we realize this, the distinction between the empty room and the solid furniture begins to blur. Everything is mostly nothing. The universe is a vast ocean of emptiness, sprinkled with tiny isolated islands of energy that we call matter. In our journey to find who created nothing, we are realizing that nothing is the default state of reality. It is the canvas upon which the painting of the universe is sprayed. But this canvas is not blank. It is textured. Even if we manage to remove the matter, the light, the neutrinos, and isolate ourselves from gravity, we are left with the fabric of space itself. And modern science tells us that this fabric is not quiet, it is alive. In the 1950s, the physicist John Archibald Wheeler imagined the microscopic structure of this empty space. He described it as quantum foam. If you zoom in far enough, past the atom, past the proton, down to the Planck length, the smallest possible unit of distance, space ceases to be smooth. It becomes a bubbling, boiling turmoil. In this quantum foam, the laws of cause and effect break down. Up becomes down before becomes after. It is a place where virtual particles pop into existence and disappear again in a fraction of a second. Space and time themselves twist and knot into wormholes and microscopic black holes that vanish as quickly as they appear. This is the nothing that underlies everything. It is not a placid, silent void. It is a dynamic, effervescent froth of potential. It is a lawless quantum world where probability rules over certainty. This realization is both dizzying and calming. It means that true absolute nothingness, a state of zero energy, zero matter, and zero potential, may not exist in our universe. Nothing is actually something. It has properties, it has rules, it has a nature. But this bubbling foam is happening at a scale so small that it is beyond our comprehension. A scale where the entire observable universe was once compressed into a space smaller than a proton. For us, lying here in the macro world, the nothing feels different. It feels like stillness. It feels like the pause between breaths. So let us step back from the microscope. Let us stop looking for the tiny vibrations of the quantum foam. Let's return to the human scale of emptiness. We have cleared our room. We have quieted the noise. We have acknowledged the invisible forces that permeate the dark. And now we are ready to leave this room entirely, to find a silence deeper than any earthly silence, and a darkness deeper than any earthly night. We must leave the planet. We must travel out past the atmosphere, past the moon, and past the orbits of the planets. We are going to journey into the gaps. We are going to explore the regions of the cosmos where the stars are so distant that they are merely faint smudges on the velvet curtain of the night. We are going to visit the cosmic archipelagos, the islands of galaxies scattered across the dark ocean of the universe. It is there, in the deep voids between the islands, that we might finally get closer to the answer of who created nothing. As we prepare to drift upward, let your mind hold on to that image of the atom, a tiny speck in a vast stadium. You're not just in the universe, you're made of the universe's emptiness. The silence you seek is already woven into the very fabric of your being. You're mostly space, held together by invisible forces, floating in a cosmos that is mostly dark. And in that darkness there is a profound peace waiting to be found. A peace that has existed for 13.8 billion years. A peace that was there before the first star ignited and will be there long after the last star fades. Let us go and find it. Before we drift further into the physical cosmos, we must pause and acknowledge a strange contradiction in our journey. Right now, you're likely seeking silence. You're looking for a gap in the noise of the day, a blank space where your mind can finally rest. We crave this emptiness because our modern world is so full of data, full of light, full of sound. We treat nothing as a luxury, a soft pillow on which to lay our exhausted thoughts. But it was not always this way. For the vast majority of human history, the concept of nothing was not a comfort, it was a terror. To understand the universe we live in, a universe that is arguably composed mostly of nothing, we have to understand why we spent thousands of years denying that emptiness could exist at all. This deep-seated anxiety has a name, given to it by the philosophers of antiquity and the Middle Ages: horror vacui, the fear of the empty, the fear of the void. Imagine for a moment that you're standing in the agora of ancient Athens more than 2,000 years ago. The sun is warm on the white stone, the air is thick with the scent of olive trees and the sea. In this world, the universe was seen as a complete, perfect and unbroken whole. To the great thinkers of that age, particularly Aristotle, the idea of a true vacuum, a space with absolutely nothing in it, was not just impossible, it was offensive. Aristotle argued that nature abhors a vacuum. He believed that space and matter were inseparable. To him, space was merely the container for things. If you removed the things, the water, the air, the earth, you removed the space itself. Therefore, empty space could not exist. If a gap were to open up in the fabric of the world, matter would instantly rush in to fill it, like water rushing into a sinking ship. The universe was packed tight, a cozy, claustrophobic box where everything touched something else. There was a certain safety in this worldview. It meant that we were never alone. It meant there were no gaps in reality where monsters could hide, or where the rules of existence might break down. It was a universe of contact, of continuity, a universe without silence. This fear of the void was not just about physics, it was psychological. It is a fear that still lingers in the back of our minds today. Think of how we act when there is a lull in conversation. When the talking stops and silence stretches out between two people, we feel a sudden instinctive urge to fill it. We rush to say something, anything, just to bridge the gap. We treat silence like a crack in the floorboards that must be patched over. This is the horror vacui playing out in our social lives. Or consider the way we fill our homes. We cover our walls with art, our shelves with trinkets, our ears with headphones. We seem terrified of the blank slate. We fear that if we stop doing, stop making noise, stop consuming, we might cease to exist. The ancient Greeks codified this anxiety into law. Nothing cannot be. But while the West was busy filling every corner of the map with dragons and every corner of the mind with logic, a different kind of thinking was emerging halfway across the world. In the lush, river-fed lands of ancient India, and independently in the dense jungles of the Mayan civilization, thinkers were beginning to embrace the void. They did something that the Greeks could not. They gave nothing a name. They gave it a shape. They invented zero. It is difficult for us, living in a world built on binary code and mathematics, to understand just how revolutionary the concept of zero was. Before this, numbers were used to count things. 1 apple, 2 horses, 10 stars. How could you count nothing? If you had no apples, you simply didn't mention apples. There was no need for a number to represent the absence. But the mathematicians of ancient India saw the void differently. They developed the concept of shunya, a Sanskrit word that means empty, but also implies receptive or opening. To them, the void was not a terrifying lack of existence. It was a fertile field of potential. It was the silence from which sound emerges. It was the empty cup waiting to be filled. When they created the symbol for zero, that simple, elegant circle we use today, they did something magical. They drew a line around the nothingness. They contained the void. By turning nothing into a number, they tamed it. Zero became a placeholder, a way to say, there is nothing here, and that is important. This was the first step in humanity's long journey to make peace with the dark. The invention of zero allowed us to calculate the infinitely large and the infinitely small. Without zero, we could not describe the distance to the stars. Without zero, we could not describe the microscopic world of the atom. Without zero, the binary code that allows you to hear my voice right now would not exist. But when this concept travelled from the east to the west, arriving in Europe during the Middle Ages, it was met with deep suspicion. Zero was dangerous. It represented the void, and the void was associated with chaos, with the abyss, with the absence of God. To stare into the nothing was to risk losing your mind. For centuries, humanity stood on the precipice of this realization, caught between the Aristotelian comfort of a full universe and the terrifying infinite potential of the zero. We built our cathedrals high to fill the sky, we wrote complex symphonies to fill the silence, and we devised intricate models of the heavens where celestial spheres nested inside one another, like Russian dolls, ensuring that not a single inch of space was wasted. But the void was patient. It waited. As the Renaissance dawned, the cracks in the full universe began to show. We began to look up, really look up, and realize that the stars were not painted on a ceiling just above our heads. They were distant suns burning in a vast, cold ocean of emptiness. The psychological shift that occurred was profound. We had to move from a mindset of horror vacui to a mindset of amor vacui, the love of the empty. We had to learn that space was not a mistake. It was the canvas. Think about the music you enjoy. If a pianist were to play every note on the keyboard simultaneously, holding them down without lifting their fingers, it would not be music. It would be noise. It would be chaos. What makes a melody beautiful is not just the notes, it is the spaces between the notes. It is the rhythm of silence. The music needs the nothing to give shape to the something. This is the lesson that the universe has been trying to teach us for 13.8 billion years. The emptiness is not a defect, it is the necessary condition for existence. As you lie there now, allow yourself to feel the historical weight of this realization lifting off your shoulders. You do not need to fill this moment. You do not need to fill your mind with plans for tomorrow or memories of yesterday. You do not need to embrace the horror vacui. You can embrace the zero. Imagine your mind as that ancient Sanskrit circle, a simple, closed loop. Inside the loop, there is a protected space, a space where the noise of the world cannot enter. This is your personal zero point. It is not a place of lack, it is a place of potential. Just as the universe began from a singular point of seemingly nothing, your rest begins from this point of stillness. The history of our species is a history of learning to trust the dark. We moved from huddled fires and caves, fearful of the shadows, to building telescopes that peer into the deepest, darkest patches of the sky to find the origins of time. We learned that the dark is not empty, it is deep. And so, we return to the room you are in, but with a new perspective. The empty space around you is no longer a vacuum that nature abhors, it is a sanctuary. The silence is not a gap in the conversation of life, it is a pause for breath. In the next stage of our journey, we are going to leave philosophy behind and test this emptiness with our own hands. We are going to watch as the brave scientists of the 17th century finally dared to pump the air out of the jar, proving Aristotle wrong and proving that nothing could be created right here on Earth. We'll see what happens to a ringing bell when the air is stolen away. We will see what happens to a feather when it falls in a void. But for now, rest in the knowledge that nothing is not your enemy. It is the oldest, most patient friend you have. It is the zero from which you came, and the zero to which you return every night when you close your eyes. Let the horror fade. Let the vacuum embrace you. Let the emptiness hold you up, like water holding a ship, not rushing in to sink you, but buoying you toward the shores of sleep. The universe is vast, and most of it is empty, and that is exactly how it should be. It gives us room to breathe. It gives us room to dream. It gives us room to be. Now, as the concept of the void settles in your mind, not as a terrifying abyss, but as a gentle container, we are ready to conduct our experiment. We are ready to create the first true nothingness. We are ready to silence the bell. With the fear of the void slowly receding in our minds, we leave the ancient marketplaces and the philosophical debates behind. We step forward in time into the dim candlelight of a 17th century laboratory. It is here that humanity stopped running from nothingness and decided, for the first time, to try and build it. This is the era of the glass vessel and the brass pump. It is the beginning of the classical vacuum. Imagine a heavy glass jar shaped like a bell resting on a wooden table. Inside this jar there is a simple mechanical bell, rigged to ring continuously. At first the sound is clear and sharp, piercing the quiet of the room. The jar is full of air, and as we know, air is a thick soup of molecules, bouncing and colliding, carrying the energy of the ringing bell to the glass, and then to your ears. The air is the bridge that sound travels across. But now we begin to turn the crank of the vacuum pump. With every rotation, we're physically dragging the air molecules out of the jar. We're thinning the soup. We're widening the gaps between the atoms. As the pump works, something remarkable happens. The frantic movement of the striker against the bell continues. The metal is still hitting metal with the same force, but the sound begins to fade. It grows fainter, distant, as if the bell is moving away from you, though it hasn't moved an inch. Eventually, as the last significant pockets of air are stripped away, the bell falls silent. You can see the hammer striking. You can see the vibration. But there is no sound. By removing the something, we have killed the noise. We've created a pocket of silence in a noisy world. This experiment, simple as it seems, teaches us a profound lesson for sleep. Silence is not just the absence of noise, it is the absence of the medium that carries the noise. To find true rest, we must mentally operate that pump. We must thin out the thoughts, the worries, and the sensory inputs that bridge the gap between the chaotic world and our inner peace. We sever the connection, and in doing so, we invite the silence in. But creating a vacuum is not just about silence, it is about stillness. And in the language of physics, stillness has a direct equivalent: cold. To understand the deepest levels of nothingness, we must talk about temperature. In our daily lives, we think of heat and cold as sensations on the skin. But to a physicist, temperature is little more than a manifestation of a particle's energy, its motion, or how fast it is vibrating. Imagine the air in that bell jar again. When it is warm, those nitrogen and oxygen atoms are furious, zipping around at breakneck speeds, crashing into one another. This chaotic dance is what we call heat. As we cool the jar down, we're essentially stealing the energy from those particles. They become sluggish. The dance slows to a waltz, then to a crawl. If we continue to extract heat, pushing the temperature down, 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 past the freezing point of water, past the freezing point of air itself, we approach a theoretical limit. Scientists call this absolute zero, or 0 Kelvin. Absolute zero is the ultimate nothing of motion. It is the lowermost limit where particles hypothetically would come to a complete shuddering stop. At this point there is no vibration, no collision, no heat. The atoms would stand perfectly still, frozen in time. It is a state of perfect crystalline rest. However, just like the perfect vacuum, nature resists this final step. We can get incredibly close. Scientists have cooled atoms to within a billionth of a degree of absolute zero, but we can never quite reach the finish line. The laws of quantum mechanics ensure there is always a tiny residual jitter, a stubborn refusal of the universe to ever be completely absolutely still. but we can look to the cosmos to see how close nature gets on its own. As we leave our imaginary laboratory and float back up into the vast expanse of the universe, we find that the cosmos is a very cold place. 13.8 billion years ago, the universe began in a state of unimaginable heat, but it has been expanding and cooling ever since. In the modern universe, the fiery depths of stars are rare islands of heat. The vast majority of reality is the empty space between them, and this empty space shivers at just a few degrees above absolute zero. When astronomers point their telescopes into the darkest patches of the sky, looking away from the stars and galaxies, they measure the temperature of the nothingness itself. And remarkably, they find it is almost exactly the same everywhere they look. 2.7 Kelvin. That is minus 270.45 degrees Celsius. It is a temperature so cold that it freezes nitrogen into a solid rock. It is a temperature where almost all motion ceases. This pervasive chill is the cosmic microwave background, the fading heat from the Big Bang itself, stretched out and cooled down over billions of years. Think about this scale for a moment. The universe is 93 billion light-years in diameter, and almost all of it, 99.99% of that volume, is sitting at this deep, dark, restful temperature of 2.7 Kelvin. We often think of the universe as a violent place, full of exploding supernovae and crushing black holes, and those things do exist, but they are the exceptions. The rule of the universe is cold, the rule is quiet, the rule is stillness. The default state of our reality is a deep, hibernating sleep. This classical vacuum of deep space is not a terrifying emptiness, it is a preservative. In the cold, nothing decays. In the cold, nothing changes. It is a timeless state. When we look out at the gaps between the stars, we are looking at a stillness that has persisted for eons. As you lie in your bed, you can borrow this stillness. Visualize the warmth of your body as a small protected island, much like a star. But around you, let your mind expand into the cool, quiet vacuum. Imagine the particles in your own body slowing down. Not to the point of freezing, but slowing their frantic daylight dance. Your heartbeat slows, your breath lengthens. The electrical impulses in your brain, which have been firing rapidly all day like the molecules in a hot gas, begin to space out, they drift apart, the frequency drops. You're mimicking the evolution of the universe itself. You're moving from the hot, dense, energetic state of your waking day into the cool, expanded, transparent state of sleep. We're drifting towards that theoretical horizon of absolute zero. Not a death, but a shuddering stop. A pause. A moment where the vibration ceases and the system finds equilibrium. But as we drift through this classical vacuum, floating in the 2.7 Kelvin quiet of intergalactic space, we begin to notice that the emptiness is not uniform. We're not just floating in a blank void. We're floating in a sea that is populated by islands. The universe is not just a random scattering of stars, it has a structure, it has a geography, and to understand the true scale of nothing, we must now turn our gaze to the things that define the emptiness. We must look at the cosmic archipelagos, the great swirling islands of light that drift in this dark ocean. For between these islands, the nothingness stretches for distances that defy the human mind. The vacuum we created in the jar was small. The vacuum of the universe is a chasm so wide that light itself grows tired crossing it. Let us leave the cold comfort of the classical vacuum and begin our journey across the deep gaps. Let us navigate the archipelago of the night. As we leave the freezing quiet of the classical vacuum behind, we let our imagination drift upward and outward. We're no longer in a room or even in a laboratory. We are floating in the deep velvet blackness of space. From this vantage point, the universe reveals its true structure. We often think of space as a chaotic scattering of stars, like a spilled bag of glitter. But when we step back far enough, a pattern emerges. The stars are not scattered randomly, they're gathered together. They huddle in vast swirling cities of light that we call galaxies. And between these cities there is the ocean. Astronomers often speak of galaxies as cosmic islands. This is not just a poetic metaphor, it is the most accurate way to visualize where we live. Imagine the universe as a dark, limitless sea. In this sea there are archipelagos, chains of islands shining in the dark. Our galaxy, the Milky Way, is just one of these islands. It is a self-contained world, a spiral harbour holding hundreds of billions of stars. But tonight, we're interested in the water between the islands. We are interested in the gaps. To understand the scale of this nothingness, we have to look at our nearest major neighbour, the Andromeda Galaxy. Andromeda is a massive spiral, even larger than our own home, but it lies across a gulf of emptiness that is staggering. The distance between us is about 2.5 million light years. These numbers can be hard to hold in the mind as we drift towards sleep. So, let's shrink the universe down to a human scale. Imagine that our entire Milky Way galaxy, all those billions of stars, all the nebulae, and our own solar system is the size of a single dinner plate. If the Milky Way is a dinner plate floating in the dark, then Andromeda is another dinner plate, and at this scale, it would be sitting about 4 meters away. Think about that image. 2 china plates suspended in a dark room separated by 12 feet of silence. Between them, there is nothing but empty air. That is the reality of the cosmic archipelago. The islands are bright and crowded, but the ocean is vast. Now imagine yourself drifting in that gap between the plates. You're in the intergalactic medium. Here, the nothing is profound. Inside a galaxy, the stars are separated by light years, but they are still neighbours. Out here, the distance to the nearest star is measured in millions of light years. If you were floating here, the sky would be almost completely black. You would see no familiar constellations. You would see only faint, fuzzy smudges in the distance, the glow of the islands you left behind. It is a place of absolute solitude. But is it truly empty? As we look closer at this dark ocean, we find that even here, the universe refuses to be completely nothing. The space between galaxies is not a perfect void. It is filled with a thin, ghostly presence. Drifting through this darkness are rogue stars, suns that were flung out of their home galaxies during ancient collisions. They wander the intergalactic deep alone, shining their light into the void, too far from any galaxy to be considered part of one. They are the hermits of the cosmos. There are also clouds of gas, mostly hydrogen, spread so thinly that a cubic meter of this space would be emptier than the best vacuum we can create on Earth. Yet, because the space is so large, this gas adds up. It forms a bridge between the islands, and underneath it all, there is something we cannot see. The islands are connected by invisible threads of dark matter, like the submerged ridges of a mountain range connecting islands beneath the ocean's surface. Filaments of dark matter stretch across the gaps, holding the archipelago together. So, the emptiness is not a separation, it is a connection. It is the silence that makes the music of the stars audible. It is, as astronomers have beautifully described, one silence between 2 songs. Let yourself rest in that silence. Imagine you're floating in that calm gap, suspended between the gravity of 2 great galaxies. You're not falling, you're not drifting away. You're held in the balance of the deep, but the universe is deeper still. If we pull back even further, leaving our local neighbourhood of galaxies behind, the scale of the nothing grows terrifyingly large. We leave the local group and move out into the vast structure of the universe itself. Astronomers have mapped the cosmos and found that it looks like a web, a cosmic web. The galaxies are arranged in long, thin strands and walls, like the foam of bubbles or the neurons of a brain. But what lies between the strands of the web? Here we find the great voids, These are the true deserts of the universe. Between the clusters of galaxies lie enormous regions of space, hundreds of millions of light years across, that are almost completely empty. One of the nearest is the gap between our neighbourhood and the Virgo cluster, a gulf of 60 million light years. That is 60 million years of travel at the speed of light through a region where there is almost nothing at all. These intercluster voids are some of the most empty regions in existence. They are vast bubbles of silence. If you were in the centre of one of these great voids, the galaxies would be so far away that you might not even know they existed. You would be bathed in total darkness, unaware of the universe of light beyond the horizon. Most of the universe is not filled with things, it is filled with these voids. The stuff, the stars, the planets, the people, is just a thin coating on the edges of these great bubbles of nothingness. This might feel lonely, but in the context of sleep, it is a gift. It means that the universe is spacious. It is not crowded. It is not cluttered. It has room. Think of your own mind as a mirror of this cosmic web. You have your thoughts, your memories, your bright clusters of activity, but they are surrounded by vast open spaces. You have room to think. You have room to breathe. You have room to drift. The great voids remind us that emptiness is the rule and noise is the exception. The universe is mostly quiet, and tonight we're simply aligning ourselves with that cosmic quiet. We're letting the bubbles of nothingness expand in our minds, pushing the noisy galaxies of our day to the very edges until we're floating in the centre of our own peaceful dark void. And yet, as we float here in the macro scale of the universe, surrounded by millions of light years of silence, a question arises. We have looked at the very large and found it empty. But what happens if we look at the very small? If we were to take a microscope to this empty space, to the vacuum between the galaxies, would it still be empty? Or is there a secret hiding in the fabric of the nothingness itself? To answer this, we must shrink down. We must leave the giant voids and dive into the subatomic world. We're about to discover that the nothing is tricking us. We're about to discover the quantum foam. Before we shrink ourselves down to the subatomic level to find the hidden energy of the vacuum, we must first go in the opposite direction. We must travel outward to the largest scales of existence, to find the places where nothing has conquered something. We have spoken of the gaps between stars and the gaps between the galaxies in our own neighbourhood. We've imagined the silence between the Milky Way and Andromeda. But in the grand architecture of the cosmos, those gaps are merely cracks in the pavement. To find the true cathedrals of silence, we must look at the shape of the universe as a whole. When astronomers map the positions of millions of galaxies stepping back to view the cosmos in its entirety, they do not see a random scatter of light. Instead, they see a structure that looks remarkably organic. They see a vast network, a cosmic web of light and darkness that resembles a sponge, or the intricate veins of a leaf, or the neural pathways of a brain. In this web, the galaxies, the homes of all the stars and planets and life we know, are merely the bright threads. They are clustered into thin filaments and walls that stretch across hundreds of millions of light years. But the threads are the exception. The majority of the volume of the universe is not the web itself, but the empty spaces between the strands. These are the great voids. Imagine a sponge. The structure of the sponge is defined not by the material it is made of, but by the holes it contains. The universe is built the same way. The galaxies lie along the walls of these bubbles, while the interiors are enormous regions almost empty of galaxies. These voids are the dominant feature of our reality. Most of the universe is not filled with galaxies, but with emptiness. Tonight, let us drift into one of these great voids. Let us journey to the region known as the Bootes Void, often called the Great Nothing. To enter this space is to leave the comfort of the cosmic archipelago behind. We are leaving the filaments of light where the galaxies cluster together like busy cities. We're sailing out into the open ocean. The Bootes void is a sphere of almost absolute emptiness, roughly 330 million light-years across. It is a gulf so large that it is difficult for the human mind to process. If we were to travel at the speed of light, the fastest speed in the universe, moving at 300,000 kilometers every single second, it would take us 330 million years to cross from one side to the other. That is a journey longer than the time dinosaurs walked to the Earth, and for the entire duration of that journey, you would encounter almost nothing. If you were floating in the center of this great void, the view would be radically different from the night sky we see from Earth. Here on Earth, we are buried inside a galaxy surrounded by the bright lights of our neighbors. Our sky is crowded with stars, but in the center of the void, there would be no Milky Way band stretching overhead. There would be no familiar constellations. There would be no sense of crowding. The sky would be almost completely dark, because the nearest galaxies would be hundreds of millions of light years away. Their light would be so faint that our human eyes could not detect it. You would look up into the blackness and see nothing but an endless, uninterrupted, velvet night. Only with a powerful telescope would you be able to spot the faintest smudges of the distant galactic walls scattered thinly across the void. It has been said that if the Milky Way had been located in the center of the Bootes void, we would not have known that other galaxies existed until the 1960s. We would have believed that our galaxy was the only object in the entire universe, alone in an infinite sea of darkness. This isolation sounds terrifying to the active mind, but for the sleeping mind it is a paradise. It is a place of absolute lack of distraction. In the void there is no noise, there is no traffic, there is no news, there is only the deep, resonant hum of the cosmos itself. And even this hum is quiet. The only things that truly fill this space are the thinnest, most tenuous whispers of reality. There is the cosmic microwave background, that ancient afterglow of the Big Bang passing through the dark like a ghost. There are the stray atoms of hydrogen gas, spread so thin that they never touch. And there is dark matter, the invisible scaffolding that holds the shape of the void, stretching through the gaps like invisible spider silk. But mostly there is space, pure unadulterated space. These voids are not static, they are growing. As we rest here, we can feel the gentle, relentless expansion of the universe. On these large scales, gravity has lost the battle. The galaxies in the walls are not falling toward each other. They are being pulled apart by the expansion of space itself. The voids are swelling. They're getting larger, deeper, and darker with every passing second. This expansion is driven by dark energy, a mysterious force that pushes space outward. It ensures that the nothing is winning. The universe is becoming more spacious. The gaps are widening. The silence is deepening. We often think of growth as the accumulation of things, gathering more possessions, more memories, more connections. But the universe grows by adding more space. It grows by adding more silence. It evolves by pushing things further apart, giving each island of light more room to breathe. As you lie in your bed, imagine that you're mimicking this cosmic expansion. Visualize the thoughts in your mind as galaxies, bright, clustered, noisy knots of energy. Now imagine the space between those thoughts beginning to expand. Just as the great voids push the walls of galaxies apart, let a gentle nothingness push your thoughts apart. Let the distance between one worry and the next grow from a few inches to a few miles, then to a light year, then to 1,000,000 light years. Soon the thoughts are so far apart that they can no longer communicate. They can no longer collide. They are isolated islands drifting away over the horizon. You're left in the center of your own personal Bootes void. It is dark here. It is cool. It is still. There is no need to rush to the next thought. It is too far away. There is no need to solve the next problem. It is on the other side of the universe. Here, in the center, you can simply float. This emptiness is not bad space. It is the canvas on which the universe exists. Without these vast gaps, the galaxies would blur together into a chaotic mess. The universe would lose its structure. The voids provide the contrast. They provide the background that makes the light meaningful. In a way, the gaps give the universe its form just as much as the galaxies do. They provide the silence that makes the music of the stars audible. So do not fear the empty spaces in your mind tonight. Do not fear the blankness of sleep. It is not a loss of self, it is a gain of space. It is a return to the natural state of the cosmos. Most of reality is empty. To be empty is to be in harmony with the universe. And yet, the universe is a place of paradoxes. We have travelled to the larger scales and found that nothing dominates. We have found that the voids are the rule and the something is the exception. But if we were to look closely at this emptiness, if we were to take a magnifying glass to the centre of the great void, would we find that it is truly empty? If we could zoom in on a single cubic centimetre of this deep, dark intergalactic space, removing the stray hydrogen atoms and blocking out the background radiation, what would be left? We would be left with the fabric of space-time itself. And this is where the story of nothing takes a sharp and fascinating turn. Because as it turns out, space is not just a stage, it is an actor. We are about to leave the macro world of light years and superclusters. We are about to collapse the scale, shrinking down smaller than a galaxy, smaller than a star, smaller than a planet, smaller than the room you're in. We're going down to the scale of the atom, and then impossibly further. We're going to find that the nothing we've been resting in is actually teeming with a secret life. We're going to discover that the silence is an illusion, and that beneath the surface of the void, there is a bubbling, boiling ocean of energy that never sleeps, even if we do. But for now, take one last look at the great void. Feel its immensity. Feel the luxury of a space that is 330 million light-years wide and completely free of obstacles. Let that vastness wash over you, clearing the clutter of the day. You're floating in the great nothing, and it is holding you. Now, let us begin the descent. Let us shrink. Let us peer into the very grain of the vacuum. We have spent the last portion of our journey drifting through the immense silent cathedrals of the cosmic voids. We have rested in the gaps between galaxies, comforted by the idea that the universe is vast, spacious, and mostly empty. From that high vantage point, space looks like a smooth, dark ocean, a perfect, unbroken sheet of glass stretching out for millions of light years. But as any sailor knows, the ocean only looks smooth from a distance. If you fly high enough above the Pacific, the water appears like a sheet of blue plastic, motionless and flat. But if you lower yourself down, inch by inch, the texture begins to reveal itself. You see the swells. You see the chop of the waves. You see the whitecaps and the spray. And if you put your face right up to the water, you see the bubbles, the foam, and the swirling chaos of the current. The fabric of the universe behaves in exactly the same way. The smoothness of the nothing is an illusion of scale. To understand the true nature of the void, we must now undertake a journey of shrinking. We are going to leave the macroscopic world of light years and parsecs behind. We're going to zoom in past the scale of the galaxy, past the scale of the solar system, past the scale of the human body. We enter the microscopic realm. We pass the cells in your body, diving down to the molecules of DNA, and then further to the atoms that make them up. As we learned earlier, the atom is mostly empty space, but we're going deeper than that. We dive into the nucleus, past the protons and neutrons, past the quarks that spin inside them. We are now in a realm so small that traditional physics begins to blur. We are approaching the fundamental pixel size of the universe. In the early 20th century, a German physicist named Max Planck calculated the absolute limit of smallness. He combined the speed of light, the strength of gravity, and the quantum of action to define a unit of length that is the smallest possible measurement in our reality. This is the Planck length. It is incredibly tiny, about $1.60 times 10 circumflex minus 35 $meters. To visualize this, imagine expanding a single proton until it is the size of the entire observable universe. At that scale, the Planck length would still only be about the size of a grain of sand. It is here, at this bedrock level of reality, that the nothing we have been resting in undergoes a startling transformation. The silence breaks, the stillness vanishes. We discover that space is not empty, it is boiling. This phenomenon is governed by one of the most famous rules in quantum mechanics, Heisenberg's uncertainty principle. In the large-scale world, we are used to certainty. If a book is sitting on a table, we know exactly where it is, and we know that it has zero momentum. It is not moving. It has zero energy of motion. But in the quantum world, nature forbids this kind of absolute zero. The uncertainty principle states that you cannot know a particle's position and its momentum with perfect precision at the same time. If you know exactly where a particle is, its movement becomes wildly uncertain. Now, apply this to empty space. If we define a vacuum as a space with zero particles and zero energy, we are making a definitive statement. We are saying there is nothing here, position, and it is not changing, momentum, energy. Quantum mechanics says impossible. You cannot have zero energy for a sustained period in a confined space. The universe refuses to be completely flat. Instead, it must jitter. It must fluctuate. There must be a baseline hum of activity, a zero-point energy that can never be removed. In the 1950s, the American physicist John Archibald Wheeler gave this phenomenon a evocative name. He looked at the mathematics of this jittering space and realized that at the Planck scale, the geometry of the universe itself becomes distorted. He called it quantum foam. Imagine the foam on top of a freshly poured latte, or the sea foam crashing on a beach. It is a structure composed of millions of tiny bubbles, popping and reforming, shifting constantly. Wheeler visualized space-time in the same way. He imagined that the smooth fabric of reality is actually made of a frothy, turbulent sea of geometry. In this quantum foam, the nothing is incredibly active. It is a place where virtual particles spring spontaneously into existence. Normally we think of creation as a long, difficult process, but in the vacuum, creation is happening all the time. According to quantum field theory, empty space is filled with fields, invisible grids that stretch across the universe. Occasionally these fields fluctuate. They borrow a tiny amount of energy from the vacuum itself and convert it into a pair of particles, a particle and its antiparticle. For the briefest fraction of a second, these two particles exist. They are real. They have mass. They borrow existence from the bank of the universe, but they must pay it back immediately. Almost as soon as they appear, they snap back together, annihilate each other, and vanish back into energy. This is happening right now in the empty space in front of your nose. It is happening in the dark voids between the galaxies. It is happening inside your own body, billions of times a second. Something is popping out of nothing, dancing a microscopic tango and dissolving back into the void. Wheeler went even further. He suggested that it wasn't just particles popping in and out, but the geometry of space itself. In the quantum foam, microscopic wormholes, shortcuts through space-time, might be opening and closing spontaneously. Tiny, ephemeral black holes might be flaring into existence and evaporating in a time frame known as the Planck time, the time it takes for light to travel one Planck length. It is a lawless quantum world. In this realm, the rules of cause and effect that govern our daily lives dissolve. There is no before, no after, no here, no there. There is only the bubbling potential of the foam. This might sound chaotic, perhaps even unsettling for a mind trying to rest. A boiling universe doesn't sound very peaceful, but let's reframe the image. Think of the quantum foam not as a violent storm, but as a living texture. Think of it like the sound of rain on a roof, or the white noise of a fan. When you listen to static, it sounds like a continuous smooth shh. But if you were to slow that sound down, you would hear thousands of individual, chaotic clicks and pops. When we sleep, we often use white noise machines to drown out the sudden, sharp sounds of the night. The quantum foam is the white noise of the cosmos. It is the static hum that underlies all existence. It is the sound of the universe breathing. This realization that nothing is actually everything in potential changes our relationship with the void. We tend to think of emptiness as a lack, a deficit, a failure to exist. But the physics of the quantum vacuum tells us that emptiness is actually a fullness. It is a reservoir of infinite possibility. The void is not a barren desert, it is a fertile soil. Every particle that makes up the stars, the planets, and your body ultimately emerged from fields like these. You are, in a very real sense, a stable pattern that has risen out of the foam. You're a wave that has formed on the surface of this deep, bubbling ocean, holding your shape for a brief cosmic moment before eventually returning to the sea. There is a deep comfort in this. It means that we are never truly disconnected from the universe. Even in the deepest isolation of the Bootes void, where there is no light and no matter, the space itself is alive. It is shimmering with energy. The emptiness is not dead, it is dormant. As you lie in bed, visualize this foam. Imagine that the space around you is not empty air, but a soft effervescent bubbles. You're resting in a bath of cosmic potential. The tiny pops and shimmers of the virtual particles are like a microscopic massage for reality, keeping the fabric of space flexible and fluid. You don't have to do anything to sustain this. The energy is not coming from you. It is 0-point energy, the baseline energy that exists even when everything else is removed. It is the energy of rest. The universe, at its most fundamental level, cannot stop moving. It cannot stop being. It has a pulse. And that pulse is the quantum foam. But this discovery leads us to a strange paradox. We have found that nothing has energy. It has activity. It has a nature. And in physics, if something has energy, it usually has weight. If every cubic centimetre of empty space is filled with this bubbling energy, then empty space should be heavy. It should have mass. And if it has mass, it should have gravity. This leads us to the next great mystery in our search for the architect of nothing. We're about to discover that this nothing is not just bubbling, it is pushing. It is strong. In fact, it is the most powerful force in the universe. We're about to meet the dark twin of the quantum foam. We're about to encounter the energy that is tearing the universe apart. We're about to weigh the void. We have shrunk down to the smallest possible scales and found that the silence of the void is a mask. Beneath the stillness, the universe is bubbling with the effervescent activity of the quantum foam. We have learned that nothing is actually a restless ocean of energy, constantly borrowing and repaying existence in a subatomic dance that never ends. But this discovery brings us to a heavy realization. In the universe, we know energy and mass are two sides of the same coin. This is the lesson of Einstein's famous equation E equals sine mc square. If you have energy, you have mass. If you have mass, you have gravity. So, if every single inch of empty space is filled with this jittering, bubbling quantum energy, then empty space should be heavy. The nothing should have weight. This sounds like a contradiction. How can emptiness weigh anything? We are used to thinking of weight as the property of rocks, of planets, of lead. We think of space as the absence of weight, the place where astronauts float weightless. But if we put the universe on a cosmic scale, we find something startling. The empty space is the heaviest thing there is. To understand this, imagine taking a pie chart of the entire universe, everything that exists. We slice it up based on what makes up the cosmos. One small slice represents all the normal matter, the atoms, the stars, the galaxies, the gas clouds, the planets, and your body. Surprisingly, this slice is tiny. It makes up less than 5% of the universe. Another slice represents dark matter, that invisible scaffolding we spoke of earlier, the glue that holds the galaxies together. That makes up about 27%. That leaves a huge portion of the pie remaining, about 68%. What is this massive majority? It is not matter. It is not dark matter. It is the energy of empty space itself. Astronomers call this dark energy. We live in a universe where nothing outweighs something by more than 2 to 1. The void is not just the background, it is the main character. The stars and galaxies are just glittering dust floating on a vast heavy sea of dark energy. But this energy does not behave like the matter we're used to. Matter has gravity that pulls. The earth pulls you down to the bed, the sun pulls the earth into orbit. Gravity is a force of attraction, a cosmic hug that tries to bring everything closer together. Dark energy is different. It does not pull, it pushes. It acts as a kind of negative pressure built into the fabric of space. It is an anti-gravity force. It wants to stretch space out. It wants to make the universe roomier. For billions of years, these two titans, gravity and dark energy, fought a silent war for the soul of the cosmos. In the early universe, when matter was packed closer together, gravity was winning. It pulled the gas into stars and the stars into galaxies. It built the structures we see today, but about 5 or 6 billion years ago, the balance shifted. As the universe expanded, the galaxies moved further apart and the grip of gravity weakened. But dark energy is a property of space itself. So, as the universe expanded and created more space, it created more dark energy. The more nothing there was, the stronger the push became. We are now living in the dark energy dominated era. The battle is over and the void has won. The universe is no longer just expanding, the expansion is accelerating. The galaxies are being pushed away from one another faster and faster, carried along by the swelling tide of nothingness. This discovery was made in 1998, when astronomers watched distant supernovae, exploding stars that serve as standard candles to measure distance. They expected to see the expansion of the universe slowing down, like a ball thrown into the air slowing as it reaches the top of its arc. They thought gravity would eventually apply the brakes. Instead, they found the opposite. The supernovae were fainter than they should have been. They were further away than expected. It was as if the ball thrown into the air had suddenly attached a rocket booster and sped off into the sky. The universe is taking a deep breath, and it is a breath that will never end. It is exhaling galaxies into the dark. This concept of accelerating expansion might sound intense, but let us translate it into the language of sleep. Think of it as the ultimate release of tension. Gravity is the force of clumping, of binding, of holding on tight. It is the force of tension. It pulls things into tight knots. Dark energy is the force of letting go. It is the force of relaxation. It loosens the knots. It smooths out the wrinkles in the fabric of space-time. As you lie here, you can align yourself with this cosmic flow. Feel the muscles in your back and shoulders. Often, we hold on to tension there. We use our own internal gravity to hold ourselves together tight. Now, invite the dark energy in. Imagine a gentle negative pressure pushing the tension out. Imagine the space between your muscle fibers expanding. Imagine your body lengthening, softening, drifting apart. You're not falling apart, you're expanding. You're becoming spacious. The power of this nothing is not violent. It is vast and steady. It is a slow, inexorable drift. It ensures that the universe will not crunch back down into a crowded, hot, chaotic ball. Instead, it ensures that the future of the universe is open. It is cool. It is quiet. There is a fascinating history to this idea of the energy of empty space. When Albert Einstein was formulating his general theory of relativity, he found that his equations predicted a universe that was either expanding or contracting. He didn't like that. He wanted a universe that was static, steady and unchanging. So he added a term to his equations. He called it the cosmological constant. It was a mathematical placeholder representing the intrinsic energy of empty space, a force that would push back against gravity and hold the universe still. Later, when it was discovered that the universe was actually expanding, Einstein called this constant his biggest blunder. He thought he had made a mistake, but it turns out the only mistake was thinking he was wrong. The cosmological constant is real. It is the dark energy. The empty space does have an intrinsic energy. It does push back. Einstein's fudge factor turned out to be the dominant force in the universe. This tells us something profound about the nature of emptiness. We often think of nothing as a lack of value. We think that if we aren't doing something, if we aren't producing something, we are wasting time. We treat our own downtime as a blunder, something to be minimized. But the universe disagrees. The universe invests 68% of its energy into nothingness. It invests the majority of its existence into the simple act of creating space. If the universe values emptiness this much, perhaps we can too. Perhaps the time you spend sleeping, the time you spend staring at the ceiling, the time you spend doing absolutely nothing, perhaps that is the most important time of all. That is the dark energy of your life. It is the force that expands your mind, that pushes back against the crushing gravity of stress and obligation. Without this expansion, we would collapse. We need the void to keep us open. So, as we rest in this dark energy-dominated era, we can feel a kinship with the cosmos. We are riding the wave of the great exhale. The galaxies are drifting away, not in sadness, but in liberation. They're being given the gift of solitude, and this energy is not just out there between the stars. Since it is a property of space itself, it is everywhere space is. It is in the room with you. It is in the space between the atoms of your body. Of course, on these small scales, the Earth's gravity and the electromagnetic forces holding your atoms together are much stronger. You aren't going to fly apart, but the energy is there, a silent, hidden potential in the very air you breathe. It is a reminder that the nothing is not weak, it is strong. It is the heavyweight champion of the cosmos. It pushes the superclusters of galaxies as if they were toys, and yet it touches you so gently that you cannot even feel it. It is the ultimate gentle giant. We have now weighed the void and found it to be heavy with power. We have seen how it shapes the destiny of the universe, pushing the horizon further away every second. We have learned that the nothing is the engine of the future. But what about the past? If the universe is expanding, getting bigger and emptier every day, then if we run the clock backward, it must have been smaller and fuller. We're about to take a journey back in time. We're going to rewind the cosmic movie. We will watch the galaxies drift back together. We will watch the dark energy yield to gravity. We will watch the vast cold voids shrink and heat up. We're going to travel back 13.8 billion years to the moment before the expansion began. We're going to ask the ultimate question of our journey. Before there was a universe, what was there? Was there a nothing before the something? Or is the question itself a trap? We're going to the edge of time. We're going to the Planck era. We are going to the moment when the nothing exploded. We have spent our time tonight drifting through the vast, quiet spaces of the modern universe. We have rested in the dark energy that pushes the galaxies apart, and we have floated in the effervescent bath of the quantum foam. We have seen that the nothing of today is heavy, active and vast. But to truly understand the origin of this nothingness, we must now do something impossible in the physical world, but easy in the world of dreams. We must reverse the flow of time. Imagine that we have a dial in our hands, a heavy brass dial that controls the clock of the cosmos. As we turn it backward, the expansion of the universe begins to reverse. The galaxies that were fleeing from one another stop, turn around and begin to drift closer. The vast voids we explored, those deserts of silence like the Bhutas void, begin to shrink. The islands of light, the Milky Way, Andromeda, the distant clusters, draw nearer to one another, closing the gaps of the cosmic ocean. As we spin the dial faster, billions of years melt away. We watch the universe become crowded. We see the galaxies merge and dissolve into clouds of gas. We see the stars go out one by one, deconstructing back into the dust from which they were born. The universe is getting smaller. It is getting hotter. It is getting denser. We pass the time when the Earth was formed 4.5 billion years ago. We pass the time when the first stars ignited, bringing light to the Dark Ages. We pass the era of the cosmic microwave background, when the universe was a foggy, opaque ocean of light. We keep going, pushing back through the darkness, back to the very first second, and finally, we arrive at the wall. We arrive at 13.8 billion years ago. We have reached the starting line. Everything we know, every galaxy, every star, every atom, every photon of light, and even the fabric of space itself, is now compressed into a single point. This is the singularity. It is here that we confront the ultimate question of nothing. It is the question that every child asks, and every physicist dreads: what was there before this? If the universe began at this moment, who created the nothing that it expanded into? What was sitting there waiting for the Big Bang to happen? It is a question that seems to demand an answer. Our human minds are built on the logic of cause and effect. If a match is struck, someone must have struck it. If a seed grows, it must have been planted in soil. We instinctively feel that the universe must have exploded into something, an empty room, a void, a blank canvas that was already there. But modern cosmology offers us a different, stranger, and perhaps more soothing answer. The famed cosmologist Stephen Hawking once proposed that asking what came before the universe is not a difficult question. It is a meaningless one. He offered a beautiful analogy to help us rest with this paradox. Imagine you are an explorer walking north. You walk past the cities, past the forests, across the ice sheets of the Arctic. Finally, you reach the North Pole. You're standing on the single point that defines north. The winds blow around you. The ice stretches out in every direction. Now, suppose someone asks you, walk one step further north. You cannot. There is no north of the North Pole. It is not that there is a wall blocking your path. It is not that there is an empty void beyond the pole. It is simply that the definition of north originates at that point. The geometry of the Earth curves in such a way that the direction north loses its meaning once you arrive there. Hawking suggested that time works the same way. The universe does not just contain time, it creates time. As we look back to the beginning, space-time curves and closes off. Just like the surface of the Earth at the pole, the beginning of the universe was the beginning of time itself. Before is a word that refers to time. If time does not exist, before does not exist. There was no empty room waiting for the universe. There was no nothing to hold it. There was simply no. This is a concept that invites a deep, heavy rest. It frees us from the need to look for a beginning before the beginning. The universe did not replace nothing. It is the only thing that has ever been. But even if we accept that before is impossible, we can still look at that first frozen moment of existence. We can look at the North Pole of time. Physicists call this the Planck era. It is a moment of incomprehensible smallness. Imagine taking the entire observable universe, all 93 billion light years of it, all 2 trillion galaxies, and crushing it down. Crush it until it is the size of a galaxy, then the size of a solar system, then the size of a planet, then a grape, then a grain of sand. Keep going. In the Planck era, the universe is compacted into a space known as the Planck length. It is a scale so tiny that it makes a proton look like a galaxy. To describe it in numbers is almost futile, but imagine a decimal point followed by 34 zeros and then a 1. That is the size of the universe in this moment. At this scale, the concepts of size and geometry begin to break down. The universe is not just small, it is fundamentally different. It is a seed of pure density. The temperature in this tiny seed is the Planck temperature, absolute hot. Just as absolute zero is the limit of cold, this is the limit of heat. It is a number so high that writing it out would require 32 zeros. At this temperature, the vibration of particles is so violent that they threaten to tear the fabric of reality apart. Matter, as we know it, cannot exist here. There are no atoms, there are no protons, there are not even the quarks that will one day build them. There is only pure, raw, undiluted potential. In this first fraction of a second, specifically the first 10 million trillion trillionths of a second, the universe is in a state that science struggles to describe. This is because our 2 best maps of reality stop working here. General relativity, which describes the curve of space and gravity, works beautifully for heavy things like stars. Quantum mechanics, which describes the jitter of particles, works beautifully for tiny things like atoms. But in the Planck era, the universe is both incredibly heavy, containing all the mass of the future cosmos, and incredibly tiny. Gravity and quantum mechanics are forced to shake hands, and right now, we do not know how they do it. They're fundamentally incompatible. This means that the origin of the universe is veiled in mystery. It is a lawless quantum world where the rules haven't been written yet. Gravity was the first force to manifest, separating itself from the others, but we don't know how it behaved in that crush. Was it a smooth point, or was it, as John Archibald Wheeler suggested, a quantum foam of distorted geometry? Some theories suggest that in this era, space and time were so tangled that you could not tell them apart. Perhaps the universe was not a point, but a loop, or a vibrating string, or a shard of an 11-dimensional reality colliding with another. We do not know, and in the context of sleep, this not knowing is a relief. It means we have reached the bottom of the rabbit hole. We have stripped away the furniture, the air, the light, the atoms, and finally, time itself. We have arrived at the seed of the cosmos and found that it is a mystery. This tiny, hot, dense point held everything. It held the potential for the stars that would one day light up the dark. It held the potential for the carbon that would form your body. It held the potential for the mind that is wondering about it right now. It was the ultimate something disguised as nothing, and it did not stay that way for long. The nature of this seed was instability. It could not hold its breath forever. It contained too much energy, too much pressure, too much possibility to remain a singularity. Something had to give. The nothingness had to break. In the next stage of our journey, we will watch the seed open. We will witness the moment when the Planck era ended and the Big Bang truly began. We will see how a tiny speck of quantum probability inflated into a universe vast enough to hold us. But for now, rest in the Planck era. Visualize that single shining point in the dark. It is the only thing that exists. There is no space outside of it. There is no time before it. There is just the unity of the beginning. It is the ultimate focus. A single dot of silence before the symphony begins. Hold that dot in your mind. Let it be the anchor for your rest. Small, perfect, complete. This is where we came from. This is the moment before the noise. This is the stillness of the North Pole of time. If you try to visualize this moment, do not try to picture an explosion. The Big Bang is often misunderstood as a bomb going off in an empty room, sending shrapnel flying out into the void. But as we have learned, there was no room. There was no void outside. Instead, imagine the universe as a deep breath being held. The Planck era is that moment of suspension. The lungs are full, the potential is peaked, everything is gathered in the centre. It is a moment of extreme tension, but also extreme balance. All the forces, gravity, electromagnetism and the nuclear forces are indistinguishable. They're melted together into a single super force. It is a time of unity. In our modern world, we see things as separate. We see light as different from matter. We see gravity as different from electricity. But in the Planck era, they were all one. This unity is a comforting thought to drift on. It suggests that at the core of reality, underneath all the complexity and chaos of our daily lives, there is a fundamental oneness. We are not fragments scattered in the dark, we are expressions of a single, unified origin. As the seconds, or rather the fractions of seconds tick by, this unity begins to tremble. The energy is too high to be contained. The temperature is too hot to be stable. We're standing on the precipice of the greatest event in history. We're standing on the edge of the expansion. But before we take that step, before we let the universe grow, let us linger just a moment longer in the before. Let us appreciate the smallness. In a world that is obsessed with more space, more things, more noise, there is a quiet power in the less. The Planck era represents the ultimate less. It is the universe stripped of all its baggage. It is the universe before it made mistakes, before it got complicated, before it got loud. It is the nothing that contained everything. As you lie in the dark of your room, you can mimic this state. You can pull your awareness inward. Forget the room outside, forget the street, forget the city. Pull your focus into the center of your chest. Find that single quiet point within yourself. That is your personal singularity. That is your North Pole. It is the place where the noise stops. It is the place where the timeline of your day ends and the timelessness of sleep begins. You're not just resting in a bed. You're resting in the concept of the origin. You're returning to the seed. And just like the universe, you do not need to do anything to make the next phase happen. You do not need to force the sleep to come. The nature of the singularity is that it eventually expands on its own. The nature of the seed is that it grows. All you have to do is hold the space. All you have to do is exist in the quiet. The Planck era eventually ended. The universe cooled, the forces separated, the gravity broke free, and the great expansion began. But for tonight, in the safety of our sleep, we can stay here. We can stay in the single point. We can stay in the unity. We can rest in the moment before the moment. So, let the image of the vast expanding universe fade for a while. Let the image of the spinning galaxies dissolve. Let the image of the empty voids collapse, bring it all down, smaller, quieter, still, down to the grain of sand, down to the atom, down to the point. This is the center. This is the silence, this is the beginning, and in this beginning there is nothing to fear. There is only the deep, heavy, warm potential of a universe waiting to be born. Rest here, in the North Pole of time, in the heartbeat before the beat, in the nothing that is everything. We have spent some time resting in the Planck era, holding that single microscopic point of infinite potential in our minds. It is the North Pole of time, the seed of everything that will ever be. But as we know, a seed does not stay a seed forever. The nature of the universe is movement. The nature of the nothing is to become something. For a long time in the history of science, there was a deep puzzle about how this transition happened. When we look at the universe today, especially when we look at the oldest light in the sky, the cosmic microwave background, we see something that shouldn't be there. We see perfection. We see a universe that is remarkably smooth. It is the same temperature everywhere we look, roughly 2.7 degrees above absolute zero. Whether we look to the deep north of the cosmos or the deep south, the temperature is identical. This is strange because in a chaotic, violent explosion, you would expect lumps. You would expect hot spots and cold spots, areas of extreme density and areas of emptiness, like the debris field of a bomb. You would expect a universe that looks like a crumpled, messy bedsheet, full of wrinkles and folds. But instead, the universe looks like a sheet that's been pulled perfectly tight. It is smooth, it is flat, it is uniform. For decades, this smoothness was a mystery. It suggested that something happened in the very first fraction of a second to iron out the wrinkles of the cosmos. Something took the chaos of the beginning and stretched it until it was perfect. In December of 1979, an American theoretical physicist named Alan Guth was puzzling over a different problem. He was thinking about magnetic monopoles, isolated magnetic particles that theories predicted should be abundant in the universe, but which we had never found. While working on this, late one night, he stumbled upon a mechanism that would solve both mysteries at once. He realized that the nothing, the empty space of the early universe, possessed a strange, repulsive energy, and for the briefest sliver of time this energy took control. This is the era of inflation. It happened incredibly quickly. It began around a trillionth of a trillionth of a trillionth of a second after the Big Bang. At this moment, the universe was dominated by a force field known as the inflaton field. This field acted like a reverse gravity. Instead of pulling things together, it pushed space apart, and it did so with terrifying, beautiful speed. In less than a trillionth of a second, the universe did not just expand, it inflated exponentially. To understand the scale of this, and to feel the soothing rhythm of this expansion, we need to use an analogy. We need to visualize the power of doubling. Imagine you have a single gigantic piece of paper. It is impossibly thin, let's say 1/10 of a millimeter. Now, imagine folding it in half. It is now double the thickness. It is still tiny. Fold it again. It doubles again. It is now 4 times the thickness. Fold it a third time. 8 times the thickness. This is exponential growth. It starts slow. The first few folds don't seem like much. After 7 folds, the paper is as thick as a notebook. After 10 folds, it is as thick as your hand is wide. But if you keep folding, the numbers begin to explode. The power of doubling takes over. By 23 folds, the paper is a kilometre thick. By 30 folds, the stack of paper reaches space 100 kilometres up. By 42 folds, it reaches the moon. By 51 folds, it reaches the sun. Now, imagine folding it 81 times. At this point, our stack of paper is as wide as the Andromeda Galaxy, 140,000 light-years across. And finally, imagine folding it 90 times. This is the number of doublings that Alan Guth proposed for the universe during inflation. At 90 folds, our single thin piece of paper would be bigger than the entire Virgo supercluster of galaxies. It would be 13 million light-years thick. This is what happened to space. In a time frame too small to measure with human clocks, the universe went from the size of a subatomic particle to something macroscopic. It expanded by a factor so large that it has no name. This sudden, silent ballooning is what put the bang in the Big Bang. It took the hot, dense, tiny seed we are holding in our minds and stretched it out. This stretching is crucial for our sleep journey because it explains the emptiness. It explains why the universe feels so spacious. Imagine drawing a squiggly, chaotic line on a balloon. The line represents the quantum jitters, the bumps and the chaotic wrinkles of the early universe, the lumps of matter, the twists of gravity. Now imagine blowing that balloon up to the size of the Earth. What happens to the squiggly line? It gets stretched. It gets pulled so tight that if you were standing on it, it would look like a perfectly straight, flat line. Inflation took the chaos of the quantum foam and stretched it until it was smooth. It took the intense curvature of space and flattened it out. It took the magnetic monopoles, those heavy magnetic particles that should have cluttered the cosmos, and pushed them so far apart that we would likely never find one. It created the vast, smooth, quiet canvas that we rest in today. When we look at the dark night sky, we are looking at the result of this inflation. We are looking at a universe that was blown up so huge, so fast, that the stuff inside it became diluted. The nothing became the dominant feature. This leads us to one of the most beautiful concepts in all of physics, often called the ultimate free lunch. You might ask, where did all the energy come from to make a universe this big? You cannot create energy from nothing. That is the first law of thermodynamics, but inflation offers a loophole. In physics, gravity is considered negative energy, because you have to put energy in to pull things apart against gravity. Matter, on the other hand, is positive energy. Alan Guth and other cosmologists realized that as the universe inflated, the amount of positive matter energy and the amount of negative gravitational energy might have perfectly cancelled each other out. The total energy of the universe might be zero. The universe may not be a collection of expensive things, it may be a perfect balance that sums to nothing. It is a quantum fluctuation that just got really, really big, and then, just as quickly as it started, the inflation stopped. The field that was driving this massive expansion, the inflaton field, decayed. It lost its stability, and as it collapsed, it dumped all of its pent-up energy back into the universe. This moment is called reheating. The cold, empty, stretched-out universe was suddenly flooded with energy. The nothing became something. The vacuum gave birth to the first particles. This is the moment when the universe as we know it truly began. The quarks, the electrons, the neutrinos, they all sprang into existence from the decaying energy of the void. We are quite literally made of inflated nothingness. As you lie there, feel the spaciousness of this idea. Your mind often feels crowded, like the pre-inflation universe, cramped with thoughts, worries, lists and memories. It feels dense and hot. Imagine that an inflation field is sweeping through your mind right now. It is taking that cramped knot of thoughts and stretching it out. It is doubling the space, and then doubling it again, and then doubling it again. The thoughts are still there, but they are being pushed miles apart. The wrinkles of worry are being smoothed out into a flat, calm plane. The chaos is being diluted by the vastness of the expansion. You're expanding, you're becoming vast, you're becoming smooth. The violence of the expansion is over. The universe has settled into a slower, steadier rhythm, but the legacy of that first trillionth of a second remains. It gave us the space we need to exist. It created the silence between the stars. The universe is vast because it inflated. It is empty because it stretched, and it is quiet because the noise was smoothed away. But the universe was not yet safe. We had space and we had energy, but we did not yet have the stable matter that makes up a quiet room, a warm blanket, or a sleeping mind. To get there, the universe had to survive a war. The reheating filled the cosmos with particles, but it created them in a dangerous way. It created them in pairs, matter and antimatter, light and dark, positive and negative. And these pairs were born enemies. We're about to enter the era of the broken mirror. We're about to witness the great battle between matter and antimatter and discover just how lucky we are to be here at all. For now, simply rest in the smooth, flat, vast expanse of the inflated universe. Feel the horizon stretching out infinitely in every direction. There are no bumps, there are no walls, there's only the open, endless plain of sleep. You're floating on the surface of a universe that breathed in, expanded, and made room for you. Let yourself drift on that expansion. Let the doubling carry you further and further away from the center, further and further away from the noise, until you are resting in the quietest, most distant corner of the cosmos. Good night to the inflation, good night to the expansion, and welcome to the smooth, silent dark. We have watched the universe inflate from a speck to a colossus. We have seen the nothing stretch out to become the vast stage of the cosmos. But now, the stage is set for a conflict that will determine the fate of everything. It is still less than a second after the beginning. The inflation has stopped, and the energy of the vacuum has been converted into a hot, dense soup of particles. We are no longer in the vacuum, we're in the inferno. This is the grand unification epoch. In this intense heat, temperatures reaching trillions of degrees, the forces of nature as we know them were melted together. We tend to think of the forces of nature as distinct and separate rulers. Gravity holds us down to the bed. Electromagnetism powers the neurons in our brains and the lights in our room. The strong nuclear force holds the atoms of our bodies together. But in the early universe, it was too hot for these distinctions. The identity of the forces was lost in the energy. To understand this, visualize a coin spinning on a table. When the coin is resting, it has two distinct faces, heads and tails. You can choose one or the other, but when you flick it and it spins rapidly, the faces blur. It becomes a sphere of motion. You can no longer tell if it is heads or tails. It is a single, unified object with characteristics of both. The early universe was like that spinning coin. The electromagnetic force and the weak nuclear force were blurred into a single electro-weak force. At even higher energies, the strong force was merged with them into a grand unified force. It was a time of perfect symmetry. It was a faceless force spinning in the dark, but as the universe expanded, it cooled, and as it cooled, the coin began to wobble. The energy dropped, the spinning slowed down, and eventually, the coin fell. The symmetry broke. The forces split apart. The strong force broke away first. Then the electromagnetic force separated from the weak force. And with each split, the universe underwent a phase change, like water freezing into ice or steam condensing into water. The rules of reality crystallized, and in this cooling, matter began to appear, but it did not appear alone. For every particle of matter created from the energy of the Big Bang, every electron, every quark, every neutrino, there was a twin created alongside it, an antiparticle. Antimatter is not science fiction, it is very real. It was predicted by the English physicist Paul Dirac in 1928, who realized that the equations of quantum mechanics allowed for particles with the opposite charge. Just 4 years later, a physicist named Carl Anderson found one in a cloud chamber. An anti-electron called a positron is identical to the electron in your body, except it has a positive charge instead of a negative one. The laws of physics demand balance. In the beginning, there should have been equal amounts of matter and antimatter, a perfect symmetrical reflection. For every left hand, there was a right hand. For every proton, an antiproton. But there is a problem with this perfection, a problem that would have made our sleep and our existence impossible. When matter and antimatter meet, they do not coexist. They do not bond. They destroy each other. They annihilate instantly, turning their mass back into pure energy, pure light. So, the early universe was a battlefield of constant creation and destruction. Particles of matter and antimatter would pop into existence from the pure energy, meet their twins and vanish in a burst of gamma rays. It was a chaotic, self-cancelling dance, a flicker of existence followed by a return to the void. If the universe had remained perfectly symmetrical, this annihilation would have been complete. The matter would have destroyed the antimatter, and the antimatter would have destroyed the matter. They would have cancelled each other out entirely. The result would have been a universe filled with nothing but light. No stars, no planets, no carbon, no us. Just a bath of radiation cooling forever in the dark, a universe of pure ghostliness. But something happened. A flaw appeared in the mirror. For reasons that physicists still do not fully understand, perhaps related to the behaviour of neutrinos or a quirk in the weak force known as charge parity violation, the balance tipped. The universe developed a slight preference. It was a tiny, almost insignificant imbalance, but it was enough. For every 1 billion particles of antimatter, the universe created 1,000,000,001 particles of matter. Think about that ratio. It is razor thin. It is like flipping a coin 2 billion times and getting heads just one extra time. But that single extra particle changed destiny. The great annihilation continued. The billion antimatter particles found their billion matter partners and destroyed them, filling the universe with light. But that single, lonely extra particle of matter had no one to destroy it. It had no partner. It was a survivor. It was a leftover. Everything we see today, every galaxy in the Hubble Deep Field, every star in the Milky Way, every grain of sand on Earth, and every cell in your body is made of those leftovers. We are the 1 in a billion sparks that refuse to go out. This realization brings a strange heavy comfort. We often feel that we are small and insignificant in the face of the cosmos. But in a very real way, we are the victors of the oldest war in history. We are the anomaly. We are the something that survived the attempt to return to nothing. And the nothing that surrounds us, the vast empty space between the stars, is the graveyard of that battle. Have you ever wondered why space is so empty? Why the galaxies are so far apart? Why the islands of light are separated by such vast oceans of darkness? It is because the annihilation was so thorough. The universe is mostly empty because most of the matter did destroy itself. The billions upon billions of particle pairs wiped each other out, leaving behind only the vast empty space and the sea of radiation. The silence of space is the silence after the storm. It is the quiet of a room that has been cleared. The light from that great battle is still with us too. The energy released when all that matter and antimatter died did not disappear. It stretched out as the universe expanded. It cooled down. It shifted from blinding gamma rays to X-rays, then to visible light, and finally to microwaves. It became the cosmic microwave background that we spoke of earlier, the 2.7 Kelvin hum that fills the nothingness. That static on the radio, that background warmth of the universe, is the echo of the great annihilation. It is the ghost of the antimatter that didn't survive. As you rest, think of yourself as that one particle, the survivor. The universe tried to cancel everything out to return to a state of pure energetic equilibrium. But you are here. You possess mass. You possess form. You possess consciousness. You are the broken symmetry. You are the beautiful flaw in the perfect glass. Even today we see traces of this mirror world. Bananas, which contain radioactive potassium, emit a positron, an antimatter particle, roughly every 75 minutes. But it is instantly annihilated by the matter around it. The dominance of matter is absolute, and now the battle is over. The antimatter is effectively gone. The universe has settled down. The survivors have clumped together to form the islands of light we call galaxies. The era of chaos has passed. The era of structure has begun. We have traced the history of nothing from the first seed through the inflation that stretched it, to the annihilation that emptied it. We see now that the void is not just a lack of things, it is a result. It is a consequence of history. It is the peace that follows the creation. The emptiness is a hard-won luxury. It is the space that was cleared so that we could exist. But the story of nothing is not just about the past. It is also about the future. The universe is expanding, the dark energy is pushing the galaxies apart. The stars are burning through their fuel. We're moving towards a new kind of nothingness. Not the chaotic, hot nothingness of the beginning, but the cold, still, eternal nothingness of the end. We are moving towards the great quiet. In the final stages of our journey tonight, we will look forward We will look to the end of time. It sounds frightening, but in the context of sleep, it is the ultimate promise of rest. We're going to watch the universe slowly turn off the lights. We're going to watch the final settling of the cosmic dust. We're going to visit the era of entropy. For now, simply rest in the knowledge that you are made of the winning side. The matter in your body is stable. It has survived the fire. It has survived the annihilation. It has earned its rest. The universe is calm now. The forces are separated and distinct. The gravity holds you gently. The electromagnetism keeps your atoms apart. The strong force keeps your center together. You're a stable island in a vast, quiet sea. Let the history of the battle fade. Let the energy dissipate. Let the survivor rest. We have spent our journey tonight looking backward. We travelled to the moment of the Big Bang, witnessed the great inflation that stretched the universe smooth, and watched the battle between matter and antimatter that cleared the stage for the stars. We have seen how the nothing of the past was actually a heavy, violent, and energetic force that shaped everything we know. But to truly understand the nature of emptiness, we must now turn our gaze in the other direction. We must look forward. If the universe began with a Big Bang, a moment of intense heat and activity, how will it end? Will it crunch back down into a singularity? Will it rip apart, or will it simply fade away? The clues lie in the dark energy we discovered earlier. Remember, this is the mysterious force that makes up 68% of the universe and is pushing the galaxies apart. It is the energy of empty space, and because space is expanding, there is more dark energy today than there was yesterday. This means the push is getting stronger. The universe is not just expanding, it is accelerating. As we look into the deep future, we see a destiny that is profound in its stillness. Physicists call it the heat death of the universe, but a better name for our purpose tonight might be the Great Quiet. Imagine we're time travelers, drifting forward on the river of time. We pass our current era, where the universe is filled with bright, burning stars. We move billions of years into the future. As the expansion accelerates, the first thing we notice is that the sky is emptying out. Right now, we can see trillions of galaxies, but the space between them is stretching so fast that distant galaxies are being carried away from us faster than the speed of light. This creates a cosmic limit known as the event horizon. Any galaxy that crosses this horizon is lost to us forever. Its light can no longer bridge the gap. It simply fades from view, slipping into the unobservable dark. It is like standing on the shore of an ocean, watching ships sail away. One by one, they drop below the curve of the Earth. Eventually, the ocean is empty. In the distant future, perhaps 100 billion years from now, observers in our galaxy will look up and see nothing. The other galaxies will have drifted so far away that their light will never reach us. The universe will appear to be dark and static, consisting only of our own local group of stars. The cosmic web will be gone, the great clusters will be gone. The universe will have returned to a state of solitude, but we drift further. We move trillions of years into the future. Stars are not eternal engines. They have fuel tanks. They burn hydrogen into helium, then helium into heavier elements. Eventually, the fuel runs out. The massive stars explode and die. The smaller stars, like our Sun, will puff off their outer layers and settle down as white dwarfs, slowly cooling over eons. One by one, the lights go out. The rate of star formation slows down as the gas in the universe is used up or flung out into the void. The universe becomes dimmer. The brilliant white and blue stars fade to red, and the red stars fade to black. We enter the black hole era. In this distant time, the only things left are the corpses of stars and the massive black holes that have swallowed everything else. It is a universe of gravity and ghosts. But even black holes are not immortal. As the physicist Stephen Hawking theorized, they slowly leak radiation, Hawking radiation. Over unimaginable stretches of time they evaporate. They dissolve back into the vacuum, and finally we reach the end of the line, the dark era. In this era, even the black holes are gone. The universe consists of a thin soup of photons and neutrinos, spread out over distances so vast that they effectively never interact. The temperature drops closer and closer to absolute zero. The universe reaches a state of maximum entropy. Entropy is the measure of disorder, but it is also a measure of rest. When entropy is maximized, nothing can happen anymore. There is no flow of energy, there is no heat moving to cold, everything is the same temperature, everything is still, the universe has become a perfect frozen lake. This sounds melancholic to the active mind, but to the sleeping mind it is the ultimate permission to rest. The universe is not designed to work forever. It is designed to run its course and then stop. It is designed to return to the peace from which it came. The nothing wins in the end. But it is not a defeat. It is a completion. The universe began as a hot, dense knot of tension, and it spends its entire life unraveling that tension, smoothing itself out until it finds perfect equilibrium. We are currently living in the brief, bright flash of the stelliferous era, the era of stars. It is a momentary awakening in a cosmos that is destined for an eternity of sleep. So, when you close your eyes tonight, you're aligning yourself with the destiny of the universe. You're letting your own internal stars, your thoughts, your anxieties, your plans, burn down to embers. You're letting your own entropy increase. You're letting the order and structure of your day dissolve into the disorganized, peaceful drift of dreams. You're practicing for the great quiet. We have traveled a long way tonight. We started in the room where you're lying, imagining the air being pumped out of a jar. We traveled to the deep, cold spaces between the galaxies. We shrank down to the quantum foam, where space boils with the energy of creation. We went back to the single point of the Big Bang and forward to the final fading of the light. And in all this travel we have circled around one central question: who created nothing? The answer, it seems, is that nothing was not created. Nothing is the canvas. Nothing is the baseline. Nothing is the ocean in which we swim. We learned that the universe is mostly empty space. We learned that the stuff we care so much about, the matter, is just a tiny impurity in the void, a 1 in a billion survivor of the Great Annihilation. We learned that the universe is dominated by dark energy, the energy of nothingness. So what does this mean for us, right now, as we try to sleep? It means that we do not need to be afraid of the dark. The dark is not an alien force. It is our home. We emerge from the void, we are sustained by the void, and one day the matter that makes us up will return to the void. We often feel that we need to be something, we need to be productive, we need to be seen, we need to be loud. The horror vacui, the fear of the empty, drives us to fill every silence with noise and every moment with action. But the universe teaches us a different lesson. It teaches us that being nothing is a valid state. In fact, it is the most common state in existence. There is a profound relief in this. It means you do not have to hold the universe together. You do not have to keep the planets spinning. You do not have to keep the stars burning. The forces of nature, gravity, electromagnetism, dark energy, are doing that for you. You're free to simply be. Recall the image of the galaxies as islands. We are living on an island of light surrounded by an ocean of peace. Tonight you're allowed to walk to the edge of that island. You're allowed to dip your toes into the silence. Think of the great voids we visited, those bubbles of empty space millions of light years across. Imagine that you can wrap yourself in one of them. Pull the void around you like a heavy velvet blanket. It blocks out the noise, it blocks out the light, it creates a sanctuary where nothing is required of you. In this sanctuary there is no past to regret, because we have seen that the past was just a singularity. There is no future to fear because we have seen that the future is just a gentle fading into rest. There is only this moment, this breath, this quiet. The science of the universe is often presented as a collection of cold, hard facts, but when we look closely we see that it is also a source of deep, spiritual comfort. We are not separate from the nothingness. As the astronomer Carl Sagan famously said, we are star stuff. But we're also space stuff. We are the universe looking at itself. We are the way the void became aware of its own existence. And just as the universe breathes, expanding out, cooling down, settling into rest, so do you. Your breath is the echo of the Big Bang. The inhale is the inflation, the expansion, the gathering of energy. The exhale is the entropy, the release, the return to the quiet. Inhale and feel the potential of the singularity. Exhale and feel the peace of the heat death. You're a microcosm of the cosmos. You contain the entire history of time inside your cells. And tonight, you're allowed to shut down the factory. You're allowed to turn off the lights of your personal galaxy. Let the thoughts drift away like those distant galaxies crossing the event horizon. Let them slip into the unobservable dark. You don't need to chase them. They're moving away from you, carried by the dark energy of sleep. Let the quantum foam of your mind settle. The bubbling, popping activity of the day is slowing down. The virtual particles of worry are annihilating back into the vacuum. The surface of the ocean is becoming smooth again. You're returning to the state of the classical vacuum. Cold, still, silent. There is no one who created nothing. Nothing is simply the pause between the notes. It is the silence that makes the song possible. And you've played your song for the day. You've added your melody to the universe. Now, it is time for the pause. It is time to trust the nothing. It held the universe before the stars were born. It holds the galaxies as they drift through the dark, and it will hold you now as you drift into dreams. The universe is vast, and it is steady. It is not going anywhere. The atoms in your body are stable. The gravity of the earth is constant. The dark energy is gently pushing the noise away. Everything is in its place. Everything is as it should be. You can let go, drift out into the gap, float between the islands, rest in the void. Good night.